Physics Part 393. Joule is inconveniently large unit to use for nuclear calculations. A more convenient energy unit is a mega electron volt, MeV, as many energy changes that take place in the nucleus are of the order of several MeV. 1 mega electron volt is the energy gained by one electron when it is accelerated through a potential difference of 1 million volts. Since electrical energy is equal to charge into potential difference and the electron charge is 1.6 into 10 power raised to minus 19, 1 MeV is equal to 1.60 into 10 power raised to minus 19 into 1.00 into 10 power raised to 16, or 1 MeV is equal to 1.6 into 10 power raised to minus 13 joules. The energy equivalent of the mass defect of helium nucleus is thus 4.4 into 10 power raised to minus 12, 1.60 into 10 power raised to 13 equals to 28.1, 28.4 MeV. If mass is measured in U and the energy in MeV, 1 U is equivalent to 931 MeV. Binding energy. This is our section 13.9. Within the nucleus, there are strong forces which bind the protons and neutrons together. To completely separate all these nucleons requires energy. This energy is referred to as a binding energy of nucleus. Stable nuclei, those which have little or no tendency to disintegrate, have large binding energies. Less stable nuclei have smaller binding energies. Similarly, when neutrons and protons are joined together to form a nucleus, this binding energy must be released. The binding energy is the energy equivalent of the mass defect. We have seen the binding energy of helium-4 nucleus is 28.4 MeV, and 28.4 MeV of energy is required to separate to infinity the 2 protons and 2 neutrons of this nucleus. Binding energy is the energy equivalent of the mass defect of a nucleus. It is the energy required to separate to infinity all the nucleons of a nucleus. We've got an example for you. Calculate the binding energy in MeV of a carbon-14 nucleus with a mass defect of 0.109736 U. Using the equivalence 1 U is equal to 931 MeV, 0.109736 U is equivalent to 102 MeV. Since the binding energy is the energy equivalent of the mass defect, the binding energy 102 MeV. Now it's your turn. Calculate the binding energy in MeV of nitrogen-13 nucleus with a mass defect of 0.108517 U. Next, we talk about stability of a nuclei. A stable nucleus is one which has a very low probability of decay. Less stable nuclei are more likely to disintegrate. A useful measure of stability is the binding energy per nucleon. The nucleons in the nucleus. Binding energy per nucleon is defined as the total energy needed to completely separate all the nucleons in a nucleus divided by the number of nucleons in the nucleus. Well, the figure shows the variation with nucleon number of the binding energy per nucleon for different nuclides. The most stable nuclides are those with the highest binding energy per nucleon. That is, those near point B on the graph. Iron is one of those stable nuclides. Typically, very stable nuclides have binding energies per nucleon about 8 MeV.